Hello everybody, it's time for video 5 of week 2. I know the past 2 videos are a little bit more nitty gritty and a little less exciting. There are both parts that come in this class. This video will hopefully be back towards the exciting. What I want to talk to you about today is the deep time of astronomy. I want to talk to you about the age of the universe, the age of the solar system, and then we're going to borrow from my favorite scientist, Carl Sagan. And we're going to go through what's called Carl Sagan's cosmic calendar. All right, so we're still in Unit 1, Part 1, topic number 3, but we're closing out the number of videos for this week. Let's just start with some basic information of how old is the universe and how old is the solar system, and let's put that into a little bit of perspective, and that's what we'll spend the majority of this video doing. Because not only are we dealing with the absolutely largest volumes of space and distances that we can imagine when we talk about astronomy, but we're also talking about all of time. So we need to know how old the universe is, and it's remarkably old or remarkably young. It's really kind of hard to scale that whenever we're talking about billions of years, and we have billions of years stretching out in front of us in the future. So what is the age of the universe? So our current estimated age for the universe, or at least from this one reference, and all the references are agreeing these days, is 13.798 plus or minus 0.037 billion years. Let's just go ahead and round that off to an easier to remember number, 13.8 billion years, or 13.8 gigayears. So we know the age of the universe to be 13.8 billion years. I do want to take a moment, because I'll be talking about this in one of the upcoming videos about science itself. In science, we are never giving you exact numbers and saying that is the answer. That's just not what we do. We're not in the business of proving things. We're in the business of giving you our best estimate given the evidence that we have, measured as accurately and precisely as we can, and then telling you how certain we are of that information. So for this reference, and this is going to be a hyperlink in the PowerPoints, hopefully it converted to the PDFs. This is determined by the NASA Planck mission, which was looking at the cosmic microwave background, and you can actually link to the articles to see where this number comes from. So this plus or minus 0.037 billion years, or plus or minus 37 million years, gives us a range. So we are 68% confident that the real age of the universe falls between 13.8 billion years plus or minus 37 million years. So we give a range and how confident we are that the true age is within that range. If you're curious about such things or curious about where this number comes from, please go see the reference. I try to give you that kind of information as often as I can. 13.8 billion years. Wow. Can't imagine that. It is an enormous amount of time. How does our solar system compare? Our home planetary system. And this will be the age of the solar system is going to be the age of the sun, which is going to be the age of the earth, which is going to be the age of all the planets. So we're really talking about how old is the earth, because we're talking about how old is our solar system. We all formed at the same time. Our current estimate for the age of the solar system, and this one has a little bit more precision on it, is 4.5682 plus or minus 0.00017 billion years. So let's just go ahead and round that off to an easy to remember number that you can recall, 4.6 billion years old. Not nearly as old as the universe itself. It took a long time after the formation or the start of the universe and Big Bang, which might just be the start of time, not the start of the universe, but the start of meaning of talking about a universe. It gets very, very confusing talking about all that stuff. But it took quite a while before our solar system came around. It's only 4.6 billion years old. And we determine the age of the solar system by looking at meteorites. We can do radioactive dating on a variety of different isotopes in there. So this particular number is considered one of the more robust numbers because lead dating is one of the most reliable ones. But they leverage a whole bunch of different dating techniques of different isotopes, and they do it for a whole range of meteorites, and they all converge to the same number, 4.6 billion years old. And again, if you're curious, I have the reference, so you can go see it. And to put this into perspective, how does this compare to modern humans, the so-called Homo sapiens sapiens, what we call modern humans? This number is not very well defined, but we'll go with an approximate age that we've been around for about 200,000 years in our modern form of humans. So how does that compare to, say, the age of the universe? Well, the age of the universe compared to the age of modern humans, that's about 0.01%, the age of the universe. Almost no time at all. We have barely even been a blip in existence compared to the entire age of the universe. And compared to the solar system's been around for a really long time as well. So it's only 0.004% the age of the solar system. Truly large, enormous amounts of times, especially to the human time scale. You go down to our lifetime time scales and it's even smaller. All right, so how can we start putting all of this into perspective? And we can go back to a scaling exercise, much like we did whenever we took the solar system and squeezed it down to fit into a football field. Then we saw how big the sun was and how big the planets were and how widely they were spaced. So Carl Sagan, one of the most prolific science communicators and scientists of all time, happens to be probably my favorite scientist when it comes to education and public outreach and communicating with people. It's a shame that he's no longer with us. But he did a scaling exercise to try to put into perspective this deep age of the universe of 13.8 billion years. He came up with this idea called the cosmic calendar. So picture the full calendar all the way from the very first moment of January 1 all the way to the last moment of December on New Year's Eve, when you're about to go ahead and celebrate the coming of the new year. So we have one full calendar year. Now take the age of the universe, the 13.8 billion year history of the universe, and squeeze it down to fit in a calendar. And then what we can do is we can put events in the history of the universe on that calendar. And that's the idea of the cosmic calendar. What we're going to spend the rest of this video doing is just talking about where some of these things are. I highly recommend, if you want to, just having a look at this. You can pause this full one and go through it in as much detail as you want, but I want to give you a little bit more information on it. So let's just start on a month-by-month basis. And let's actually figure out on this scale, on the cosmic calendar, how long is a cosmic calendar month, a cosmic calendar day, cosmic calendar hour, minute, and second. So on this scale, 1 month would be the equivalent of real time 1.15 billion years. A month is a billion years. One cosmic calendar day is 37.8 million years, mega years. 1 hour is 1.57 million years, 1.57 mega years. See, all that scientific notation and metric system stuff was quite useful. And 1 minute is approximately 26,000 years, and 1 second is 437 years. So in the time it took me to just talk about how long 1 second is, centuries passed. In fact, a millennium or two passed. Kind of crazy to think about. So let's look at some notable events on the cosmic calendar on a month-by-month basis. And we're setting the Big Bang to occur at the very first moment on Jan 1. So the very start of the year is when the Big Bang occurs, time 0. Before that, we have no information about what's really going on. You can't even define things like time. So that's the start. There are all sorts of cool events that happen in the seconds right after the Big Bang, but I want to hit some big landmarks here. So let's go with when the first stars and galaxies form, estimated to be about 300 million years after the Big Bang occurred. That would put the first stars and galaxies forming on the 8th of January. What about our home galaxy, the Milky Way? So our Milky Way galaxy, the one that we reside in, formed at about 10 to 11 billion years ago. And this is a range of dates range of ages, because we don't have a precise date. And the way that galaxies are built, they're built in sequence. So different parts of the Milky Way galaxy were built at different times. So I have to give sort of a range to pin it down. And that puts it at the Milky Way forming from March into April. And then the final part of the Milky Way really coming into place, what we call the thin disk, in May. So we have to go all the way to May just to get our Milky Way galaxy. Moving on, let's go ahead and zoom in on the last month. Because really, if we're going to talk about things that are happening on Earth that we probably recognize from our history classes and our science classes, then what we need to do is zoom in on December. Really, we're going to have to zoom in on the last day. So what are some notable dates just in the month of December? So that's what this is showing down here. So on the 18th of December, that's whenever you get vertebrates, creatures with backbones. On the 19th of December, that's whenever land plants evolve. Dinosaurs don't come around until the 25th of December. Talk about a cosmic Christmas gift. We get dinosaurs on the 25th of December. And they stick around for 5 cosmic calendar days. It takes 5 whole days for the dinosaurs to go extinct, which we in the cosmic calendar, we're here on December 31st, the very last day of the year. It was just yesterday that the dinosaurs went extinct. And December 31st, after 11:54 p.m., the final 6 minutes or so is really the age of humans, the age of modern humans. It's all kind of mind-blowing to think about that. So what we should do is maybe look at the final moments of December 31st. In fact, let's go look at the final 60 seconds of the cosmic calendar. So 11:59 p.m. on December 31st, all the way until the start of the next year. And now we can start seeing stuff that we might recognize from a history perspective, although we're not even going to be in recorded history. So 54 seconds ago would have been the end of the last ice age. 24 seconds ago is when we developed agriculture and we started to have permanent settlements, just 24 seconds ago. All of modern human history pretty much takes place, recorded history, in about the last, well, not recorded history, all of human history takes place in about the final 6 to 8 minutes of the cosmic calendar. All of recorded history, since we've been actually documenting our own history, is in the final 15 or so seconds of the cosmic calendar. The Industrial Revolution, which brought about our modern technological age, occurred only half a second ago. And to really put some things in perspective, and I decided to go through this entire scaling exercise and figure out, Dr. Lindsay, I've been alive for approximately 8.75 times 10 to the minus 2 seconds. 87.5 milliseconds is my time on the cosmic calendar. So those are the slides that I have prepared for you. That's what I wanted to talk to you about. I am going to start a discussion based on this because I always like to ask this question and just give your honest answer. Try to engage with one another. I'll be watching and our TAs will be watching, but I always like to have you contemplate on this idea of the cosmic calendar. And let's imagine that right now we're going into the next year of the cosmic calendar. So I asked the question, how long are humans going to survive? How far into the next calendar year of the cosmic calendar do humans make it? The dinosaurs had 5 days, which they made it. How long do you think humanity lasts? I'll go ahead and create a discussion on that. Hope you enjoyed this video. It's kind of mind-blowing to think about all these things. And I will see you in the next one.